All right, let's do another example here. In this one, we're going to be, again, going through the same steps. We're going to graph this rational function. So number one, I'm going to find my roots. I'll do that by saying x squared minus 9, setting that equal to 0. In this case, I'm going to have to factor this using a difference of squares. So I know I'm going to get x plus 3 times x minus 3 equals 0. And then I'll go ahead and I'll solve. And I'll get that x equals negative 3 and x equals 3. Okay, so my roots are going to be 3, comma 0 and negative 3, comma 0. Okay, so again, that's step one, finding our roots. Step two, we're going to find the discontinuities. In order to do that, we're going to set it, the denominator equal to 0. So we're going to say, all right, x squared minus 2x minus 3 equals 0. We'll go ahead and we will solve that. Again, to do that, we're going to have to factor here. I'm going to get x minus 3 and x plus 1. And when I solve this, I'm going to get x equals 3 and x equals negative 1. Now, x equals negative 1 is going to be a vertical asymptote. I can see that based off of the fact that negative 1 is not showing up as a root, and I'm seeing this factor is not also appearing in my numerator. X equals 3 is where we're going to have an issue. You can see how this factor is also showing up here in the numerator. And we can see that we said it was a root, but it's also showing up here. If that happens, that means you have a removable. Okay, I'll put an R next to this for removable. I go up here to my number one step, and I cross out this 3. This is no longer a root. It is now a removable discontinuity. Okay? Now, what does that mean for me? That's where this step 3 comes in. So step 3 is going to be us finding where this removable discontinuity is going to be graphed, okay? So how do I do that? I'm going to take this 3 and I'm going to plug it into this equation and see what I get out. Now, you're going to say to me right now, but Mr. Guy, if you plug it in, your denominator is going to equal 0 because that's what's showing up. That's why it's discontinuity. So what I'm going to do is I'm going to cancel that factor out. So in our numerator, we had this. In our denominator, we had this. And what I'm going to do is I'm going to cancel out the factor that's causing the problem. Okay? I'll then go ahead and plug 3 in and see what comes out. And I'm going to get 6 over 4, which would reduce to 3 halves. So 3, comma 3 halves is going to be my removable discontinuity. That'll make more sense in a moment when we go to graph, okay? So that's steps 1, 2, and 3. Step 4 is us finding the end behavior. So in this case, we have the same degree in the top and bottom, so we do a ratio of their leading coefficients, and that's going to be y equals 1 will be our end behavior, okay? For step 5, we're going to go ahead and find our y-intercept. Okay, that means we're going to go ahead and plug 0 in for x and see what comes out. If you plug in 0, you'll get negative 9 over negative 3, which will just be 3. So 0, comma 3 is going to be our y-intercept, okay? And then step 6, that's kind of that newer thing where we're going to go ahead and do that plus minus chart. So in this case, the points that I have a vertical I have a root at negative 3. I have a vertical asymptote at negative 1, and then I have a removable discontinuity at 3. At any of those places, we could switch from positive to negative or vice versa, so we have to check. So I'm going to go ahead and plug in a number that's less than negative 3. I wrote these numbers on the wrong side. Hold on, guys. Let's make that so it actually looks like how I wrote it before. We're going to look for numbers that are in between these. Okay, so our negative 3, negative 1, and 3. So the numbers that I'm going to pick, I will pick, let's say, negative 4. Let's say negative 2. 0 is an easy one to pick, and 4. You want to pick as easy numbers as possible. Again, any number in between those will work, but try to pick easy numbers. It makes it a little bit easier on yourself, okay? So you go ahead and plug these in and see what comes out in between. If you plug in negative 4, you'll get a positive answer. Okay, when you plug in negative 2, you're going to get a negative answer. When you plug in 0, you're going to get a positive answer. And then when you plug in 4, any number greater than 3, you're also going to get a positive answer, okay? So you'll notice it doesn't always alternate in between. You kind of have to be careful about that, all right? Let's take all this information into our last step. Let's go ahead and make our graph. So once again, I'm going to draw myself a little XY axis. I'm going to go ahead and I'll go right down the line. So first I'll plot this root at -3. So at -3, that's where I'm hitting the x-axis. I'll put a point there, okay? I have a vertical asymptote at -1. So at -1, I'll go ahead and draw my vertical asymptote. My removable at 3, I'll also plot. In order to plot that, I'll go to this point right here, 3 3/2. So if we're marking this, we'll go 1, 2, okay, 1, 2, 3. We'll say, all right, so 3 3/2 is halfway in between 1 and 2. We'll put a little open hole there to show that it's a removable discontinuity, okay? So you can see it's kind of like a point we're plotting, but we'll do an open hole, okay? Our end behavior at 1, so we're going to go ahead and put a horizontal asymptote at 1. And then we have a root at 0, 3, so we'll put a point there. Let's see what this function does. So it's going to follow this horizontal asymptote, and it needs to be positive, so it's going to be in between this x-axis and the asymptote, following that as we go, and then we'll hit the root. At the root, we're now going to be negative up into our vertical asymptote. We're going to follow that forever. We're then going to pop out on this side because we're going to pop out on the positive side. We go through my intercept, hit my removal discontinuity, and we stay positive past that and follow this out towards forever. We're going to follow that asymptote and keep going. Okay, so you can see it all lines up. It all should be consistent with what you're doing, okay? So these are the kind of problems we're looking at. You're going to be plotting your end behaviors, finding those removable discontinuities, finding your vertical asymptotes. If you have a slant asymptote, same exact thing. You just follow it as you go out, and that's kind of the deal. We're going to spend a bunch of days practicing these, make sure that we're good at these. It is going to take some time. You'll notice the first couple will take you longer. As you get better at them, you will start to go a little bit faster at them, all right? Thank you all for watching.